Okay, let's unpack this. You're likely sitting on just mountains of information, right? Reports, PDFs, images, databases, and somewhere in there is that exact nugget of knowledge you desperately need.
Mm-hmm.
Finding it quickly is tough, really tough, especially when it's not just clean text. But then how do you take that buried, unstructured data and make it genuinely useful for those cutting-edge AI applications?
Yeah, like grounding an LLM, right. So it can actually answer questions based on your specific private company data.
Exactly. It's a challenge I think every business wrestling with information faces today.
It really is the core problem, Information overload is absolutely real, and just plain old keyword search. It just doesn't cut it anymore when you need deeper understanding or want to, fuel AI insights.
Couldn't agree more. So today we're doing a deep dive into a key Microsoft cloud service designed to tackle precisely this, Azure AI Search. We've taken a stack of deep research articles, notes about this service, and our goal here is really to cut through the technical jargon, pull out the most important bits, and give you a shortcut. A shortcut to understanding what Azure AI Search is, how it works, and maybe most importantly, why it's becoming so critical, especially now with generative AI moving into the enterprise.
And it's fascinating because it didn't start with AI in the name. Its whole evolution really mirrors the industry's journey.
How so?
Well, it started with pretty basic search, then added these cognitive capabilities, making search smarter. But now it's fundamentally shifting to become a critical piece of the AI infrastructure. It's really designed now to power sophisticated AI experiences, especially RAG.
Okay, all right, let's start with the foundation then. What is Azure AI Search at its core, if you had to boil it down?
Think of it as a fully managed enterprise-scale search as a service. It lives in the Azure cloud, its main job, helping you find information buried inside all that unstructured data, even at massive scale, millions, billions of documents.
And that managed part, that's a big deal for developers, isn't it? Because Microsoft handles the tricky stuff.
Oh, absolutely. The infrastructure, the scaling, the, complex search algorithms, Microsoft takes care of that. You don't have to build or maintain all that yourself.
Which must lower the barrier significantly.
Exactly. It seriously reduces the operational burden. And what's really critical now is that it's built to power both, traditional enterprise search apps and these newer agentic R-Gray scenarios.
R-Gray being retrieval augmented generation.
Right, where an AI model needs to pull relevant context from your specific data before it generates a response. Azure AI Search provides that factual basis for the AI.
That evolution story you mentioned is pretty telling. It started as Azure Search, way back in 2013, focused pretty simply on indexing and keyword querying.
Right. The initial goal was really just simplifying search infrastructure for developers. Then came that significant step up to Azure Cognitive Search.
And that's where it got, as you said, much smarter. It integrated cognitive skills. What sort of skills are we talking about there?
Things like optical character recognition, OCR, to read text that's actually inside images, or extracting key phrases, named entities like people or places, detecting languages, even sentiment analysis.
Right.
And this was key because it allowed the service to pull information out of data formats that, well, traditional search just couldn't see into. It made previously dark data searchable.
Right, unlocking stuff trapped in images or PDFs.
Yeah.
And that brings us to today, Azure AI Search. How does that name change signal a shift beyond just smarter search?
It really represents a fundamental pivot. It's not just about making search easier or adding some smart features anymore. It's now deeply integrated with and optimized for the whole AI landscape, generative AI, vector search, RAG specifically. It's positioned as a core component for building AI applications.
So the goal now is less about just improving human search and more about enabling AI experiences.
It's definitely both, but there's a heavy, heavy emphasis on the AI side now. It's about making your data accessible and understandable to AI models so they can provide accurate, grounded responses based on your facts.
Okay, so what are some of its core capabilities then that make it ready for these modern AI-driven workloads, especially RAG?
Well, first off, it functions as an enterprise-ready vector database. And that comes with, built-in security, compliance features, responsible AI considerations baked right in.
Okay. Vector database capabilities. What else?
It really simplifies data ingestion. You can set it up to automatically pull data from various Azure services, blob storage, Cosmos DB, or even some third-party sources.
So it helps get your data in easily. What about getting it ready? Because raw data isn't usually searchable, right?
Exactly. And it offers this unified workflow for the whole data prep, indexing, and querying process. This pipeline can handle parsing documents, chunking them up.
Chunking meaning breaking large docs into smaller pieces.
Yeah, smaller, more manageable pieces, which is crucial for things like R. Then enriching the data with those cognitive skills we talked about and creating embeddings.
Ah, the embeddings, those numerical vectors that capture meaning.
Right, so it handles a lot of that heavy lifting to transform your raw data into something searchable and, importantly, AI-friendly.
Okay, that sounds pretty comprehensive.
Yeah, and plus, it offers flexible vector capabilities. You can have multiple vector fields in one index. You can combine keyword and vector search. That's hybrid search. It supports multiple languages. You can filter results based on metadata alongside the vector similarity.
So find me documents about this concept, but only the ones created last quarter, for example.
Exactly like that. And it provides advanced search features too, like re-ranking results for better relevance, query planning, autocomplete. And underpinning all of it is robust data and user protection, encryption, authentication, network isolation. Those are foundational.
And it plugs into the rest of the Azure ecosystem, open source frameworks too.
Designed for smooth integration. So putting this in your context, why does having a managed, evolving search as a service like this matter for you?
Well, I guess because building this kind of thing yourself, this scalable, intelligent retrieval system, that sounds incredibly complex.
It is. Using a managed service just dramatically lowers that barrier. And its evolution really shows where information access is headed, right? It needs to understand meaning, not just match words. And that's essential if you want to build the kind of applications people are talking about now, like an internal AI assistant that can instantly answer questions based on, I don't know, your company's entire library of procedures and reports.
Okay, so once the data is indexed, how does Azure AI Search actually find things? The source material we looked at highlights this power trio of search capabilities, full text, vector, and semantic search. They each offer a different way in.
That's a great way to put it. They offer different strengths. Full text search is, the most traditional. It's based on Apache Lucene, focuses on finding documents that contain specific keywords you type in.
How does that actually work, though, under the hood? It's more than just cheer plus F. Right?
Yeah, much more. When you send a query, first it gets parsed, broken down, then lexical analysis kicks in. It uses these things called analyzers, standard ones, or you can customize them to clean and transform your search terms.
Like getting rid of common words or stemming.
Exactly. Stemming words down to their root, removing stop words like the or a. Then it uses data structures, primarily the inverted index, to very quickly retrieve documents that contain those processed terms. Finally, it scores the documents it found, usually using algorithms like BM25, to rank them based on how relevant the keyword matches seem to be.
Got it. And you can use different query languages for that, simple or something more powerful.
Right. There's a simple syntax, which is the default, good for basic operators.
Yeah.
Or you can use the full Lucene syntax, which gives you much more power wildcards, fuzzy search for typos, rejects, searching within specific fields.
Okay. And you can tweak the ranking, make certain things more important.
Yes, definitely. Scoring profiles are a big way. They let you set up rules to boost documents. Like, say, a match in the title field should count way more than a match in the main body field. Or maybe you want to prioritize products with a lower price. You can have up to 100 of these profiles per index.
Wow.
And you can also do term boosting right inside a Lucene query using the little caret symbol to explicitly give more weight to certain search terms you think are most important.
What's interesting here, the sources point out, is that while it uses Lucene, Microsoft has really extended it and layered AI on top. It's way more than just a basic Lucene wrapper.
Absolutely.
You could think of it as the layer providing that surgical precision for exact keyword matches.
Perfectly put. Now contrast that with vector search. This is all about finding items based on their conceptual similarity, not just whether the same words appear. This uses those numerical vectors, the embeddings.
Right. This is where the machine learning models come in. They capture the semantic meaning of your content, text, images, whatever, and represent it as a point in this high-dimensional embedding space.
Exactly. And the core idea is the closer two points are in that space, the more similar their underlying concepts are, even if they use totally different words.
So search becomes finding the points closest to your query.
Precisely. It's about finding the nearest neighbors to your query vector in that embedding space. Azure AI Search uses efficient algorithms like HNSW or EKNN to do this. These are approximate nearest neighbors, or ENN algorithms.
Approximate. meaning not always perfect.
Right. They trade off a tiny, tiny bit of absolute accuracy for massive gains in speed and scalability, which is absolutely essential when you're dealing with millions or billions of vectors.
Okay, so this is the fundamental shift. We're going from what documents have these words
hmm
to what documents are about this concept.
It completely changes the game for understanding nuance, handling synonyms, different phrasings. This enables key scenarios like similarity search, finding stuff with similar meaning even if the words don't match. Multimodal search.
Like searching images using text descriptions.
Exactly. Or multilingual search, searching across different languages. And filtered vector search, where you combine that conceptual similarity with structured filters like we talked about before. And of course, it's explicitly designed to function as the vector database for array applications.
This conceptual search feels absolutely crucial for AI, doesn't it? It's how you provide that relevant context from your own data to an LLM, even if the user asks the question in a slightly different way than how it's written in your documents.
It moves beyond simple pattern matching to something closer to actual understanding. It's fundamental for good RAG.
Okay, so we have keywords with full text, meaning with vectors. Was the third part of the trio? Semantic search.
Right, semantic search, also called semantic ranking. Think of this as a premium add-on feature. It applies another layer of intelligence after the initial search results come back. It uses powerful language models from Microsoft, based on Bing technology actually, to understand the intent behind your query and significantly improve the ranking of the results.
So the first step, full text or vector, gets you a broad set of potential matches, maybe the top 50 or so. And then semantic ranking acts like a smart editor that reads through them and pulls the absolute best, most relevant ones right to the top.
That's a really good analogy. It takes those top 50 initial results, it processes key parts of their content up to about 2,000 tokens from designated fields, and then it scores each one against your query using these deep learning models. It assigns a special score, the @search.reranker score, from 0 to 4.
Higher is better.
Higher is better, yes. Then it re-ranks the original 50 results based purely on this new semantic score.
And this is where those helpful summaries come from, the captions and answers.
Exactly. As part of this semantic processing, it can generate concise captions for the top re-ranked results, usually under 200 words, that summarize why that result is relevant. And if your query looks like a question, it can sometimes extract a direct answer too.
And critically, these captions and answers are pulled directly from the original text. It's not making them up.
That's a crucial point. They are verbatim text snippets pulled directly from the content stored in the index. It finds the best existing passage. It doesn't generate new text itself.
That must make a huge difference for the user experience. You see why a result is relevant immediately.
Huge difference. So beyond just the better ranking from the deep learning models, the captions and answers significantly improve discoverability and usability for humans and for AI. These extracted snippets are absolute gold for grounding LLMs.
Why gold?
Because they provide highly relevant, concise text taken directly from your trusted source data. That's critical for reducing the risk of the LLM hallucinating or making stuff up.
What's really interesting here is that this semantic layer specifically tackles that common frustration, where search results might have the keywords but lack real context. It tries to understand your intent.
Exactly. It refines the results after that initial retrieval. And getting those precise captions and potential answers is a massive boost, both for people searching and for feeding accurate information to AI models. It's got to remember, it's powerful, but it is a premium feature, so there's a cost and maybe a performance trade-off to consider.
So putting this trio together, full text for the precise keywords, vector for the underlying meaning or concept, and semantic for understanding intent and providing context, they really complement each other.
They absolutely do. And the sources strongly suggest that hybrid search, which intelligently combines the results from keyword and vector search, often using a technique called reciprocal rank fusion, or RRF, is frequently the best approach, especially for RGA.
Why hybrid for RGA?
Because it leverages the strengths of both worlds. You get the precision of keyword matching for specific terms or codes, and you get the broader conceptual recall from vector search to catch relevant information, even if the wording is different. It casts a wider, smarter net.
Makes sense. So think about how you search online, right? How often do your keywords not quite hit the mark? This combination helps find what you need, even with different phrasing, or maybe the key info is in an image. And crucially for AI, it provides a much richer, more accurate set of grounding data for the LLM.
It gives the LLM the specific, relevant passages from your internal knowledge base that it needs to construct a trustworthy and accurate response. It directly addresses that big problem of the AI just, making things up.
Okay, so it's great at finding information. But you also mentioned Azure AI Search helps extract and structure information from your data, especially that messy, unstructured stuff. This is the AI enrichment and knowledge mining part.
Yes, exactly. This is how you unlock the value that's often hidden inside documents, images, maybe even audio files. It leverages what are called cognitive skills.
And these are like pre-packaged AI models you can just switch on.
Pretty much. They're pre-built AI capabilities that you integrate right into the indexing pipeline. So as your data is being processed before it even hits the search index, these skills can run. They can do things like OCR to pull text from images.
We mentioned that one.
Right, or extract key phrases, identify entities like people, organizations, locations, detect the language of the document, analyze the sentiment, analyze images to identify objects or scenes, even translate text between languages. They fundamentally transform that raw, unstructured data into a structured, searchable format by pulling out these key features and content.
That sounds incredibly powerful for dealing with diverse data types. What if you have really specific needs, though? Maybe analyzing unique types of legal contracts or specific engineering diagrams? Can you add your own AI logic?
Absolutely. That's where custom skills come in. This is the service's main extensibility point. You can build and integrate your own specialized AI models or custom processing logic.
Pick what?
Maybe you have a machine learning model that classifies different types of business contracts based on their clauses. Or maybe you need to integrate with a specialized third-party speech recognition service to process audio files. These custom skills typically run in an external service that you manage. Often, an Azure function is a good fit, but they hook seamlessly into the search service's enrichment pipeline.
And these built-in skills, they plug into other Azure AI services for the actual processing power.
Yes. For light usage, you get a certain number of free transactions per day across these skills. But for any significant enrichment work, you'll need to link a billable resource from the underlying services. That's usually Azure AI Vision for image tasks, Azure AI Language for text tasks, and Azure AI Translator for translation.
Okay, so there's a cost associated with heavy enrichment.
There is. And the source material also mentions different ways to handle the billing and authentication for these linked services. There's the traditional key-based authentication, but there's also a newer keyless method in public preview now. It uses managed identity, which is generally more secure, simplifies connection management, and importantly, removes the constraint that the AI service had to be in the same region as your search service.
Interesting. So this enrichment part, you can think of it as the service helping you mine your dark data, right? Extracting value from files that normal search would just ignore.
Precisely. And the custom skills mean you can apply your specific business intelligence or existing AI models right into that mining process. You just need to remember that advanced enrichment does have associated costs, and you need to pick the authentication method that best fits your security needs and architectural setup.
It's basically turning those dusty old reports and unlabeled images into structured features and searchable content. That seems incredibly valuable, both for just finding information later and for providing really rich context to AI models.
It really is. It adds layers of understanding to the raw data.
Okay, so how does all of this fit together architecturally? What are the main components we need to understand?
Well, at the absolute heart of it is the search index. This is the central data structure where all your searchable content actually lives. It's highly optimized for CPA. We're talking millisecond response times for queries.
And just to be clear, it stores the indexed content, the processed stuff, not the original raw files themselves, right?
Yeah, exactly right. It stores things like the text broken down into tokens words or parts of words. It stores the numerical vectors for embeddings if you're using vector search. It might store some unaltered text if you need it for filters or displaying snippets, but it's fundamentally optimized for search operations, not for being a general file store.
And the fields in this index, they can be simple data copied from the source, or they can be the output of all that enrichment.
Both. Some fields might just be a direct mapping, like a product ID or a date. Others will be the result of processing the text extracted by OCR, the key phrases identified by a skill, the vector embeddings generated from the content. Different types of content, like text versus images, go through specific indexing paths involving analyzers, maybe chunking, vectorization using embedding models, or image analysis skills.
Okay, that's the index. How does the data get into it? You mentioned indexers.
Yes, indexers are the automated crawlers. They implement the pull model. You basically point an indexer at a supported external data source in the cloud. Azure Blob Storage is very common. Cosmos DB, Azure SQL Database, SharePoint Online now too.
Okay.
And the indexer automatically extracts the data from that source and pushes it into your search index. You define how the fields in the source map to the fields in your index. It's super convenient because you often don't have to write any custom code for basic data ingestion.
And these indexers also trigger the enrichment pipeline, the skill sets.
Correct. When an indexer runs and pulls in a document, it can automatically trigger the associated cognitive skill set to process and enrich that data before it lands in the search index. So the typical flow is define your data source connection, define your target index schema, create the indexer linking them, and optionally a skill set, and then you run the indexer. You can schedule them to run periodically, say every hour or every 15 minutes.
And they're smart enough to only pick up changes.
Yes, they have change detection mechanisms, so they usually only process new or updated documents after the initial run, which is efficient.
This automation sounds great for handling the ETL extract, transform, load specifically for search. Are there downsides or limitations?
There are a few. The sources mention that the minimum schedule frequency is typically 5 minutes, so it's not truly real time. And indexer performance can sometimes be impacted by the overall load on your search service tier. If you need near real-time updates, like instantly indexing something the moment it changes, you usually bypass the indexer and use a push model.
Push model meaning your application code directly calls the search API to add or update documents in the index.
Exactly. More custom code, but gives you finer control and potentially lower latency for updates.
Okay, so data's in the index, either via pull indexers or push API. How do applications actually interact with it to search?
That's done via the query APIs. These APIs expose all the different ways to search that we've discussed. You can send queries using the simple or the full Lucene syntax. You can add filters or request facets for refining results. You can invoke the semantic ranker, perform pure vector searches, or run those hybrid searches combining keywords and vectors. They provide a really flexible set of tools for retrieving exactly the information you need.
And this whole architecture, the index is the enrichment, the query APIs. This makes Azure AI Search a really key component in that ARG pattern we keep mentioning.
Absolutely. It's positioned as a mature, robust, and well-established retrieval system specifically for R architectures. It acts as the dynamic searchable knowledge base. It indexes your proprietary private data and then provides that crucial grounding data back to the large language models when they need to answer a question based on your information.
And Microsoft is building integrations to make this easier.
Yes, they're integrating it more tightly with services like Azure AI Studio, which includes the Azure AI SDK and prompt flow tooling, Azure OpenAI Service directly, and Azure Machine Learning for more custom ML scenarios. The goal is to make it simpler to wire up Azure AI Search as the knowledge source for your AI applications.
So it's the system responsible for intelligently finding the most relevant snippets or chunks of context from your massive private knowledge base, which the LLM then uses to generate its response.
Precisely. Now, here's a really crucial detail that the sources explicitly call out. While Azure AI Search integrates with LLM services and orchestration tools like prompt flow, the search service itself doesn't provide native LLM integration for managing the entire conversation flow.
What does that mean in practice?
It means Azure AI Search handles the retrieval part brilliantly, but it doesn't, for example, manage the chat history, it doesn't preserve the state of a multi-turn conversation, and it doesn't orchestrate the calls between the user, the retrieval step, and the final LLM generation step.
Ah, okay. So you, the developer building the application, still need to write the surrounding code. The code that handles that orchestration, manages the conversation state, maybe formats the prompt for the LLM using the retrieved data?
Yes, exactly. Think of Azure AI Search as the incredibly powerful, specialized engine for finding the right information within your knowledge corpus. It's like a super-powered dynamic library for your organization's specific knowledge, but it's not the complete AI assistant or chatbot itself. You still need to build the application logic that actually talks to the user, manages the back and forth, calls Azure AI Search to fetch the relevant context documents or snippets, and then takes that retrieved context context, combines it with the user's latest query, and sends it off to the Azure OpenAI service, or another LLM, to generate the final grounded answer.
Okay, that makes sense. So it's the brain that remembers everything your company knows and finds the relevant facts extremely quickly. And you build a conversational part around it, the part that orchestrates the interaction and actually talks to the LLM.
That's a perfect summary.
All right, let's shift gears a bit. Where is this actually being used in the real world? And what are some practical things people need to consider if they're thinking about implementing Azure AI Search?
Well, the key use cases we're seeing heavily feature generative AI now. It's powering things like voice RAG applications where you talk to an AI that uses retrieved documents. It's the backend for many internal AI assistants or co-pilots. And crucially, it enables organizations to build custom knowledge bases using their own proprietary data.
Which is fundamental for grounding those LLMs,
Right.
making them useful and trustworthy with company-specific info.
Absolutely. It's how you reduce those frustrating hallucinations where the AI just confidently makes things up because it doesn't have the specific facts from your context.
And beyond the latest AI craze, it's still a powerful engine for more traditional enterprise search.
Oh, definitely. Helping employees find documents across all sorts of formats and internal systems. We saw that UBS example for legal search, finding specific clauses or precedents within millions of legal documents in a highly regulated financial context. That's a classic high-value use case. Or think about customer support building intelligent search into websites, or internal agent tools that can understand natural language questions and find answers in knowledge-based articles or manuals.
The sources mentioned a few other examples.
Yeah, BALH in healthcare was highlighted for using vector and hybrid search, presumably for things like matching patient symptoms to medical literature or research. Fujitsu mentioned its ease of integration as a key benefit. And Artificial, a software dev company, used it to power a RAG bot that helps users with product guidance based on documentation.
These real-world examples really show it solving concrete, often complex problems, even in regulated or technical industries.
Right. And that point about using your specific company data to ground LLMs, that's probably one of the most powerful ways right now to make generative AI genuinely useful and, importantly, trustworthy within an organization, giving it access to your facts.
Okay, let's talk about scale and performance, because finding information in terabytes of data needs to be fast. The source material is pretty clear. Good performance isn't just automatic, right? It depends on quite a few factors.
Absolutely not automatic. How you design your index composition is critical. The schema itself, the size of the documents you're indexing, and especially how you attribute fields,
What do you mean by attribute fields?
like marking fields as filterable, sortable, or facetable. Each of those adds overhead during indexing and sometimes querying. If you mark too many fields with these capabilities when you don't actually need them, it can negatively impact performance. Using complex data types in your index can also add overhead compared to simple strings or numbers.
Okay, so be thoughtful about your index design, and how you ask for information matters too, the query itself.
Oh, query design is huge. Things that can slow queries down include searching across a large number of fields at once, asking the service to return a huge amount of data, top value, using computationally expensive query types like fuzzy search or prefix wildcardic searches, especially on large fields, requesting lots of facets, or using high skip values for deep pagination. These can all add latency.
High cardinality fields too, what's that?
Fields with many, many unique values, like maybe a user ID or a precise timestamp. Using filters on very high cardinality fields can sometimes be less performant than filtering on fields with fewer distinct values, like categories or status codes.
Right. And then there's the horsepower you pay for the service capacity.
Exactly. The tier you choose for your Azure AI Search service instance makes a big difference. Higher tiers, like Basic, Standard S1, S2, S3, Storage Optimized, L1, L2, generally have faster CPUs, more memory, better network bandwidth than the lower ones or the free tier.
And the free tier is really just for playing around.
Pretty much. The documentation is clear. Use it for demos, small dev projects, but don't expect predictable performance or SLAs. Within a tier, you scale out using replicas and partitions.
Okay, what's the difference?
Replicas are essentially copies of your index. Adding replicas increases the number of queries per second QPS your service can handle and provides high availability for queries required for the SLA. Partitions divide your index horizontally. Adding partitions increases the total storage capacity and can also increase the speed of indexing because the work can be parallelized across partitions. But you need enough replicas to handle the query load distributed across those partitions.
So getting performance right is really a careful balancing act between index design, query patterns, and the underlying service capacity. Tier, replicas, partitions.
It absolutely is. You can't just throw complex queries at a poorly designed index on an underpowered tier and expect miracles. You really need to test how your specific data and your common query patterns perform at the scale you expect. Overconfiguring fields just in case or writing inefficient queries can definitely slow things down.
What are some common optimization techniques then?
Well, on the index side, design your schema carefully, only enable filterable, sortable, faceable on fields where you truly need it, optimize the size of documents being indexed. On the query side, use filter whenever possible instead of complex query clauses. Use select to retrieve only the fields you actually need. Leverage scoring profiles to influence relevance without complex query logic.
Mashing? Scaling.
Yes. Implementing caching layers in your application, maybe using Azure Front Door, a CDN, or an in-memory cache like Redis, can absorb load for frequently asked queries. Scaling the service itself by adding replicas for query load or partitions for storage indexing speed, or even moving to a higher tier. And for indexing large amounts of data, using bulk indexing APIs and designing for incremental updates is important.
Okay, lots to consider there. So putting this in your context again, listener, where could you potentially use intelligent search like this in your work or projects? What kind of data do you have that's currently locked away, maybe in PDFs or images, that AI enrichment could unlock? And if you were actually building this, what are the main levers you need to pull to balance performance and cost? Is it optimizing the index, tuning the queries, or choosing the right service tier and scaling configuration?
And tied closely to performance and scale, especially for enterprise data, are security and compliance. These are obviously non-negotiable. Azure AI Search has a lot of built-in features here.
Data is encrypted automatically, right? Both when it's moving and when it's stored.
Yes. All data in transit between your app and the service, or between the service and other Azure components, uses TLS 1.2 or 1.3 over HTTPS. That's standard. And data at rest, the indexes, the definitions, everything stored on disk by the service is automatically encrypted using service-managed AES 2506 keys. This is built-in, transparent. You don't have to do anything to enable it.
But for organizations needing more control, there's an option to use your own keys, customer-managed keys or CMK.
Correct. For an extra layer of security and control, you can configure Azure AI Search to use encryption keys that you manage in Azure Key Vault. This provides double encryption, service key plus your key, and gives you full control over the key lifecycle. You can create them, rotate them on your schedule, audit their usage, and importantly, revoke access if needed. This is often a requirement for highly regulated industries like finance or healthcare.
Okay, but there's a big caveat here, isn't there? A performance hit.
Yes, and the sources are very explicit about this trade-off. Enabling CMK encryption can increase your index size and, more significantly, it will degrade query performance. They estimate an increase of anywhere from 30 to 60% in query latency.
Wow, 30 to 60% slower queries. That's substantial.
It is. So enhanced security control is vital for some, but it comes at a performance cost that you might need to mitigate, perhaps by choosing a higher performance tier or adding more replicas, which in turn increases cost. It's a crucial balancing act.
How is access to the service itself controlled? Who can manage it? Who can query it?
There are two main mechanisms. The traditional way is using API keys. There are admin keys, full control, and query keys, read-only access for querying. But the recommended approach now is to use Azure Role-Based Access Control, RBAC, integrated with Microsoft Entra ID, formerly Azure AD.
So you use user or application identities from Entra ID.
Exactly. You can grant specific roles like owner, contributor, reader for managing the service itself, or data plane roles for programmatically accessing the content, indexing or querying, to Entra ID principles. This is generally more secure and manageable than distributing static API keys. Managed identity is also key for outbound connections, like allowing an indexer to securely access data in blob storage without needing you to store credentials within the search service configuration.
And for locking down network access, making sure only trusted sources can talk to the service.
You've got IP firewalls where you can specify allowed IP address ranges, or for maximum network isolation, you can deploy private endpoints. This uses Azure Private Link technology to give your search service a private IP address within your own virtual network. It essentially shields the service completely from the public internet, allowing access only over your private VNet or peered networks.
That sounds like the gold standard for security-sensitive environments.
It generally is. So what's notable here is that robust security features are deeply integrated, including these advanced options like CMK and private endpoints for the strictest requirements. But, as with CMK, you have to weigh those enhanced security measures against potential impacts on performance, cost, or complexity. Private endpoints, for example, require careful network planning.
The service handles different kinds of network traffic too. Inbound, outbound.
Right. There's inbound traffic from your applications sending queries or management commands. There's outbound traffic, primarily from indexers pulling data or skill sets calling external AI services or custom skills. And then there's internal traffic that stays on the Microsoft backbone between Azure services. It also adheres to a whole host of compliance standards: GDPR, IPI, ISO 27001, SOC 123, FedRAMP, many others. Microsoft invests heavily in the underlying cybersecurity.
Okay, let's try to pull this all together. Let's look at the strengths, maybe some limitations, and where Azure AI Search fits in the broader landscape compared to alternatives. What would you say are its unique strengths?
Well, that deep integration with the rest of the Azure ecosystem is definitely a major one. If you're already an Azure shop, it fits very naturally. Its advanced AI capabilities, particularly the built-in hybrid and semantic search, plus that whole AI enrichment pipeline with cognitive and custom skills, those are real standouts. It's clearly designed for enterprise use, with strong security, compliance, and scalability features available out of the box. And, as we've discussed, its specific focus and features tailored for the RG pipeline are a key differentiator right now.
Makes sense. On the flip side, what are some of the common pain points or limitations people might run into?
Well, the initial setup, especially configuring complex indexing pipelines with skill sets or fine-tuning relevance, it can require significant expertise. It's not always point-and-click simple for advanced scenarios. Cost can definitely become high, especially when you scale up to handle very large data sets or heavy query loads, or when you start using those premium features like semantic search extensively. Performance, as we talked about, can be an issue if you have very complex queries or if your index design isn't optimal for your patterns. And the sources did mention that while it's improving, handling complex typos or very unusual phrasing perfectly can still sometimes be a challenge for the core search algorithms.
So summarizing that, incredibly powerful, especially for AI and enterprise needs in Azure, but it's not necessarily simple or cheap to implement and run at scale, particularly for the most advanced features. It requires technical skill and budget.
That sounds fair. Now, looking at the competitive landscape, there are other managed services out there.
Like Amazon Kendra, Google Cloud Search.
Exactly. Those are strong competitors, especially if you're primarily invested in the AWS or Google Cloud ecosystems, respectively. They leverage their own cloud platforms and often have strong built-in ML capabilities tailored to their stacks. The choice between them might depend heavily on your existing cloud provider.
And then there's the whole world of open source options.
Right. Very popular choices like Elasticsearch OpenSearch, which is a fork of Elasticsearch, Solr, and more recently, specialized vector databases like Qdrant, Weaviate, Pinecone, Milvus. These generally offer more flexibility, potentially lower cost if you self-host them, and often have large, vibrant communities.
But the trade-off there.
The trade-off is usually significant operational overhead. You have to manage the infrastructure, the scaling, the security, the upgrades yourself, and you often need to build the integrations like connecting to data sources or AI enrichment services manually. Azure AI Search provides a managed service where many of those features, especially the deep integration with Microsoft's AI capabilities and the enterprise-grade security and compliance, are pre-integrated and managed for you.
Okay, so putting this in your context one last time, listener. Why might you choose Azure AI Search over, say, managing your own Elasticsearch cluster or using Amazon Kendra? What specific needs would make it the right fit? Maybe it's that deep Azure integration, the built-in semantic search, the specific focus on grounding LLMs with your data using RAG, or maybe the out-of-the-box enterprise security and compliance features are paramount. And conversely, when might you lean towards one of the alternatives?
To wrap things up then, Azure AI Search really stands out as a powerful, enterprise-grade, and increasingly AI-centric search solution. It's become strategically important for building effective RAG applications within the Azure ecosystem. Its core strength lies in taking all that diverse, unstructured data that companies have and transforming it into actionable knowledge using AI enrichment, and then making it discoverable through that sophisticated combination of hybrid and semantic search capabilities.
And its evolution, from just basic keyword search years ago to this deeply integrated AI functionality now, It really shows a clear trajectory, doesn't it? Towards intelligent, context-aware information access that goes way beyond just matching words on a page.
Absolutely. And looking ahead, based on the source material and Microsoft's direction, it seems pretty clear they'll continue investing heavily here. We can probably anticipate things like even tighter native integration with LLM orchestration tools, more advanced multimodal capabilities, searching across text, images, maybe even audio or video more seamlessly. Perhaps some simplification of the AI enrichment process, making it easier to configure, and maybe more granular options for controlling costs, especially around premium features. It's really positioned to be effective.
Which leaves us with a final provocative thought for you, the listener. As AI gets better and better at understanding human language, at having natural conversations, how will the ability to instantly retrieve, process, and make sense of your organization's specific knowledge, that whole mountain of internal data, the stuff only you have, how will that fundamentally change the way you work, the way you make decisions, the way you interact with information day to day? Is traditional search, the kind based purely on finding matching words, about to become a relic of the past?